Now we'll see a problem in quantum mechanics. I have taken this problem from Introduction to Quantum Mechanics by Griffiths and Shrivather. A particle in the infinite square well has as its initial wave function an even mixture of the first two stationary states. That is psi of x comma 0 is equal to a psi 1 of x plus psi 2 of x. Normalize psi of x comma 0, then find psi of x comma t and modulus of psi of x comma t squared, and then compute expectation value of x and p. So the given wave function is psi of x comma 0 is equal to a psi 1 of x plus psi 2 of x. Now we have to normalize this. So integral psi star psi dx equal to 1. So if modulus of a squared, integral psi 1 star psi 1 plus psi 1 star psi 2 plus psi 2 star psi 1 plus psi 2 star psi 2 into dx, and use orthonormalization condition, that is integral psi I star psi j dx equal to delta ij, that is I and j is equal, then we can get 1, otherwise it is equal to 0. That is, in one case it is a normalization, in other case it is an orthogonal property. So if you use this, it is equal to 2 modulus of a squared. So it is equal to 1. So a is equal to square root of 1 by 2. So psi of x comma t is equal to, it is a psi 1 of x e power minus I e1 t by h cross plus psi 2 of x e power minus I e2 t by h cross. This is for time dependent case. So you substitute the value for a, and it is 1 by 2 square root, and sin of x is square root of 2 by a sin n pi x by a, and also en is equal to n squared pi squared h cross squared divided by 2m a squared, that is equal to n squared h cross omega. So from this we can write psi 1 of x is square root of 2 by a sin pi x by a, psi 2 of x is 2 by square root of 2 by a sin 2 pi x by a. So E1 is h cross omega, E2 is 4 h cross omega. Now if you substitute all this, psi of x comma t is square root of 1 by a sin pi x by a e power minus I omega t plus sin 2 pi x by a e power minus I omega 4 minus I 4 omega t. So if you take modulus square, then we can get it is equal to 1 by a sin squared pi x by a plus sin squared 2 pi x by a plus sin pi x by a sin 2 pi x by a e power I 3 omega t plus e power minus I 3 omega t. So this is equal to 1 by a sin squared pi x by a plus sin squared 2 pi x by a plus 2 sin pi x by a sin 2 pi x by a cos 3 omega t. Now we have to find out the expectation value of x. So it is equal to x modulus of psi square dx. So substitute this value of 10 in 11, we can get 1 by a integral from 0 to a x sin squared pi x by a plus x sin squared 2 pi x by a plus 2x sin pi x by a sin 2 pi x by a cos 3 omega t into dx. So integral from 0 to a x sin squared pi x by a dx can be already derived in one of the videos. I have mentioned the link, please go through. That is equal to a squared by 4. It is also equal to integral from 0 to a x sin squared 2 pi x by a dx. Now we have to find out the for the last term. So last term, it is integral from 0 to a 2x sin pi x by a sin 2 pi x by a cos 3 omega t. This 2 sin pi x by a sin 2 pi x by a can be written as cos pi x by a minus cos 3 pi x by a. That is, you have to use cos a plus b formula and cos a minus b formula. Then we can get it is cos A minus B minus cos A plus B. And now if you integrate, then it is integral from 0 to A, x cos pi x by A is equal to, we can get 2 A by pi the whole square. The link, it's also derived in the previous video. I have mentioned the link. And similarly for integral from 0 to A, x cos 3 pi x by A dx is 2 into A by 3 pi whole squared. So now you substitute all this, the expectation value of x is A by 2 plus A by pi squared 16 by 9 cos 3 omega t. Now we have to find out the expectation value of momentum. Expectation value of momentum is m d by dt of expectation value of x. So if you differentiate, then we can get it is equal to 16 by 3 pi a by pi squared omega m sine 3 omega t. And if you substitute the value for omega, we'll get expectation value of p is 8 by 3 h cross by a sine 3 omega t. Thank you.